Assalamu alaikum. So now we will move on to chapter 4. We will talk about temperature, heat and thermal energy. So in which direction does the thermal energy flow spontaneously? So spontaneously we are talking about heat that moves from hotter to colder object. Okay? So we're talking about, the answer will be A. Which of the following processes requires no medium to transfer heat? So no medium to transfer heat, we're talking about radiation, and the biggest example for it is the sun. It radiates the energy or the light that has heat as well to the earth. Okay, so now let's move on. Here in the table we need to compare between conduction, convection, and radiation with examples. So for the conduction, how do we deliver the thermal energy? By collisions, okay, between the particles. And this one requires a medium. This one, the convection, again requires a medium. The only one that does not need a medium, which is radiation. Okay, and this one, no need for medium. Okay, how does this happen for the convection? It is by the physical movement of matter. Okay, and this one, how does it move, or how the thermal energy is transferred? By electromagnetic radiation. Okay, okay, for example, let's give some examples on conduction. For example, pan touching stove. For example, this one, we can say that hot air rising, cooling, falling, etc. This one, for example, heat from fire or anything. Okay, so for question 19, which situation we will state the process, that is it conduction, convection, or so? Getting burned by touching a hot stove, this is conduction because we have two objects touching each other. Hot air rising, this is convection. Heat from a campfire, so you have a distance, so this is radiation. Heat from the sun, again we have a distance and no medium here, so this is radiation. A slice of bread placed under a red hot electric grill to make toast, so we have a distance between the toaster and the bread, so this is again radiation. Okay, so now we will talk about the specific heat capacity of the object. So here we will discuss, so you have equal masses of four materials listed in the table. All are at the same initial temperature. If you place them in a warmer room, which material's temperature will increase the most? The material temperature that has the lowest specific heat, okay, this one will rise more. So which one has the lowest specific heat? This one. So Aslan, what do you mean by specific heat? It is the amount of energy that is needed to raise the 1 gram of the material 1 Celsius. So we need what? We need the lowest specific heat in order to raise the temperature higher. How much thermal energy is required? So they need Q to raise the temperature. We have the mass of a copper by 15 Celsius. So we have delta T. We have the specific heat, which is C. So Q equal MC delta T. M is 0.75. C is 387 multiplied by 15. So if you plug it to the calculator, and 0.75 multiplied by 387 multiplied by 15. So the answer will be 433.75 joules. Okay. What instrument is used to measure the specific heat capacity? The specific heat capacity is uses a device called calorimeter. Calorimeter, okay, which is C. Now we'll talk about subtopic 5, which is properties of liquids, or sorry, fluids. So here we have a formula called pressure equal the force over the area. If area increases, the pressure will decrease. So كل ما زادت الarea, if we have a larger area, we have a smaller pressure. Which of the following is correct for pressure? It's B, F over A. Which of the following is or are the unit for pressure? So we have multiple units for the pressure, either Pascal or in Newton per meter squared, depending on the formula, okay? So it is A and 1 and 2. The table gives 4 forces. Which row gives the largest pressure? So the largest pressure will be highest force, lowest area. So you can say that it is B, but we can do it in calculation. 20 over 2, which is 10, of course, in Newton per meter squared. 40 over 2, which is 20. 20 over 4, which is 5. 40 over 4, which is 10. So the answer is B. Which of the following statement is true about the zero or the absolute zero? Absolute zero is the temperature where all molecular motion ceases, and we don't have any type of motion. Okay? So which is D. The buoyant force is in which direction? Again, always buoyant force always acts upward against gravity. Okay? So this one, rank the reading of the scales in the figure below from the lowest to greatest. Again, from the lowest to greatest. So whenever we have masses are deeper in the fluid, this means that we have a higher buoyant force acting on the weight. So the C will be the lowest, then B, then A. A is the largest one in this situation. So whenever we have more distance inside the fluid, this means that we have a higher buoyant force that acts upon the gravity. Identify the reasons of the object if they are sinking, neutral, or floating. So here, if we look at it, we can say that weight is bigger than F, buoyant, right? So it will sink. This one is a neutral. Why? Because F buoyant is equal to the weight, which is the gravity. Here it will float. Why it will float? Because the buoyant force is larger than the weight. Okay. Now, last question. I suppose the density of water is 1 gram per centimeter cube. Which of the following substances will float in the water? Okay. Anything will float if a substance will float if the density is less than the density of water, which is gram per centimeter cube. So anything less than 1, it will float. So the answer is substance 4 only. So thank you.